Yeah. Yes.
So X is the end of the third tick mark.
Yeah.
4, 5, 6, 7. Now there here they have mentioned the 0 as well. Now X is equal to 1 by 2 means 3 tick marks is equal to 1 by 2. That means one tick mark is equal to 1 by 2 into 3. That is 1 by 6. Now if we find the value of y, we can see that y is the seventh tick mark. So 7 tick marks is equal to
1 by
1 by,
21.
1 by 6 into 7.
Yeah. Oh, yeah. 1 by
7,
7.
7 by 6. So statement 1 is answering the question.
Hmm.
Second statement is the difference between y and x. That is 4 tick marks is equal to 2 by 3. And we need to find the value of 7 tick marks. So 1 tick mark is equal to
Oh,
2 by
7
3 into
is
4.
sufficient. Yeah.
Yeah, so 7 will be equal to times 7.
Yeah.
So again 7 by 6.
Fine, fine, fine. Okay. That is very helpful. And then I had, let's see. I did one. I wanted to know, yeah, 196. So this is problem solving 196 OG15.
Okay.
Some questions I'm asking because I just want to make sure I'm using the most efficient method.
Yeah, that should be the way. Okay. So how many integers are given to us?
Let's see. From the consecutive integers, -1 and to 10. So 10, 0 to 1 second, 0 to 10 and -10 to -1.
Hmm.
1 second. So 0 to 10 will be 10 plus 10, 11 integers.
Hmm.
And -10. And hold on. So to find the number of integers, you add, no, you do -1 plus 10, 9 plus 1, 10 integers. So total of 21 integers.
Yes,
Yeah,
-1 to -10 is 10,
yeah,
1 to 10 is 10, and then 0.
yeah,
So a total of 21
yeah.
integers. Now, out of these 21 integers, we are asked to randomly choose 20 integers with repetitions allowed. That means we can choose integer multiple times. Now,
Yeah.
what is the least possible value of the product of those 20 integers? So, what should be the value of the product?
If you take one -10 and 19 tens,
Very good.
you should get the answer.
That is perfect.
So it should be
So the
E.
whole idea is it's E.
Oh, E. Okay. So, acha. Yeah,
So
you're right.
ultimately it is that we are multiplying 10, 20 times, and once the number is negative.
So it's basically -10 into 10 raised to the power of 19, which is equal to negative and then in brackets 10 raised to power of 20.
Yes, negative is outside,
Yeah.
and then so for that matter, we do not take -10 only once. We can take -10 number of times, so that ultimately the product is negative.
Okay.
We can take negative 19 times as well,
Yeah.
and once we can take positive 10.
Positive 10. Oh,
So odd number of times -10, and the remaining odd number of times positive 10.
okay.
Positive will anyways give positive value, and negative when multiplied odd number of times a negative value.
Mm, okay. Interesting. And then, me just see. One one two of
Problem solving?
let me just see. No, I think, oh, this is okay. Okay, sorry. This was 112 is of data sufficiency only. Digits and decimals. Oh yeah, in this question in digits and decimals, question 17 of problem solving, I just did it. I'll just tell you how I did it. I think we discussed it. I haven't had time to go back to the video, but quick question. In this is 0.1 plus 0.1 square. I did it like this. I did 0.1 plus 1 by 100 plus 1 by 1000. And then rewrote it as 0.1 plus 0.01 plus 0.001. And then just,
Correct.
it's fine, right?
Yeah. So it is that since you are adding, there is only one digit at every place after decimal, like 10th place, 100th place, 1000th place.
Yeah.
So everything remains same. It's just that whatever non-zero digit is there, so it will come place only.
Yeah.
So
Yeah, no, I
at
was
the
making
once
a method.
10th place, 100th place, like this.
Yeah, exactly. Question 20, 25th digit to the right. So is this just simply long division? You see
No. Actually, this is something different. We haven't reached there actually. So I generally cover this as part of percentages, but I can still explain you now. So it's one and the
Oh,
same
it
thing.
was in the digits and decimal questions, so that's why I did it.
Yeah. So it is still fine. So the whole idea is, I don't know if we have discussed it or not. I think we discussed like what all things you need to memorize: the squares, the cubes, 1 by n as percentages.
The squares, the cube. Like, can you give me an example? I'll
So
tell you.
I think I asked you to prepare a chart or something to memorize all the squares from
No,
1 to 30. No?
no, we haven't discussed squares yet.
Okay. So fine. So I'm just writing down all the things. So first is you need to memorize all the squares from 1 to 33. Cubes from 1 to 12.
Okay.
1 upon n as percentage and or decimals. The value of under root 2 and under root 3. The three algebraic formulas that we did. So these things are
So what three algebraic formulas?
this 1 upon n as percent. 1 upon n means like 1 upon 1 is 100%.
Yeah.
1 upon 2 is 50%. 1 upon 3 is 33.33%. So in percentage terms, it's 33.33. In decimal terms, it is 0.33. So when we continue like this, so the most important ones are, which are very frequently used, is 1 upon 8, which is 12.5%. 1 upon 9, which is 11.11%. 1 upon 11, which is 9.9%.
Yeah.
Now the question is asking about 6 upon 11, I guess.
Okay.
Yeah, 25th, the 6 upon 11.
Yeah.
Now 6 upon 11, we know that 1 upon 11 is 0.090909, something like this, and it goes on. So 6 upon 11 is multiplying 6 by 0.00909. So we get
Mhm. Yeah.
0.5454 like this. So the 10th, starting from 10th place, odd number places we have 5s, and at even places we have 4s. The question is asking about 25th, which
Yeah.
is odd, so it will be 5.
Yeah. Yeah, then I just counted, but I just wasn't sure. Okay, now I know how to approach this. Fine.
So you have to do n minus percentages.
Hmm.
Uh,
I
it's
think so.
good if
Yeah, we cover this in. I mean, I'll learn this now, obviously, but I'm sure we'll cover some of these in percentages.
yeah. So 1 upon n is percentages. It's good if you can do from 1t, but like 1 to maybe 12 is very important.
Okay. And then there was question 111. Let's see.
Yeah, so this I think we have done.
Yeah. I managed to get till that one over 2 cube into 5 cube into 2 to the power of 6, which means it's 1 over 1000. Actually, don't worry about this. I'll go back and I can just check it. So I don't want you to waste time on this. Or not.
So whenever you have to solve such a question, objective should always be to convert everything into zeros in the denominator,
Yeah.
because we have 2s and 5s.
Yeah.
Step 1 is to multiply by 5 to the 6 over 5 to the 6,
Yeah.
so that you have 9 tenths in the denominator, and 5 to the 6
Oh,
is
okay.
15625. Now we know that out of these 5 zeros will be consumed these 5 digits, so we will have 4 more zeros.
Hmm.
This makes sense?
Yeah.
So question can be asked in two ways: to find out the number of zeros between a decimal point and the first non-zero digit,
Yeah.
or they can ask the question, how many non-zero digits are there?
Yeah. Got it. Fine. And then there was this question number 31 DS. In the second part I'm having, this is a question of, D is equal to 0.43T7. I just want to confirm the second statement 2. If D were rounded to the nearest thousandth, the result would be 0.436. So does that mean, suppose the value of D was equal to 0.435?
Tens, hundreds, thousand, and 10,000.
Yeah.
So these 4 digits are given. So if we have to convert it till thousand, we need just 3 digits after the decimal.
Yeah.
Now we are given the answer as well, 0.436. Now 0.43 dash and 7 is given. If we are getting 0.436, we know that since the presence of 7 is there, it will the digit at the thousand place will be increased by 1.
Yeah. So it can only be 5.
It can only be 5.
Got it.
Yes.
That's what. Yeah. Can only be 5. Fine. And then 80.
DS.
Yeah.
Okay. If R and S are positive integers, can the fraction R over S be expressed as a decimal
So
with only a finite?
yeah, I got A as the answer. It's basically like it matters. The denominator only matters, right? In this case.
Perfect. So non-terminating decimal, terminating decimals are those which have only 2's and 5's in the denominator, irrespective of what is given in the numerator.
Terminating decimals.
Terminating decimal, correct. Decimal with only a finite number of non-zero digits means it's a terminating decimal.
Yeah.
And 100 is 2 square times 5 square. So that means it is a terminating decimal because we have only 2's and 5's in the numerator or denominator.
Okay. Fine. Fine. Yeah, that makes. I just wanted to confirm why. And then
Yeah,
148.
DS.
Yeah.
Any decimal that has only a finite number of non-zero digits is a terminating decimal. For example, this R and positive integers and the ratio R over S is expressed as a decimal. Is R over S a terminating decimal? Exactly same question.
Yeah. So if we know that S is equal to 4, that means it's a non-terminating decimal.
That means it is a terminating decimal.
Oh, because it has 2's in it.
Yes, it has 2's and or 5's, nothing else. So there should be nothing else.
Yeah.
Whether it has only 2's or only 5's or a combination of some 2's and 5's, it is fine.
Okay, fine.
It will be a terminating decimal. And it does not depend on the value of the numerator.
That's why, yeah, that's why S is what matters. I mean, I understood that I was noticing that the denominator was the one that decides if it's a terminating or non-terminating, but I just didn't know.
Yeah. Now the point is, you may be give example, S is equal to 28.
Yeah.
Now what will be the answer?
S is equal to 28, 7 4 0 9. So then it's not a non-terminating decimal.
So what will be the answer?
Then it'll be E.
Why E? That is the question. Why not? Why cannot you say that we will certainly get non-terminating?
Sorry, why can't we say that?
We certainly get a non-terminating decimal.
No, because there between 90 and 100, there must be a multiple of 7 in there, which will terminate.
Correct. That is right. So 91 and 98 are two such numbers.
Yeah.
If we are given the value of R, a precise value of R,
yeah,
then we will still get the answer. Whether the answer is a definite yes or a definite no.
Yeah, so suppose 1 was 91 and 2 was 28. Then obviously,
correct.
Right?
Then you are terminating decimal.
Yeah.
And it doesn't matter. The point here is, even if we get 92 over 20 and 28,
we'll have an answer.
Even then we have a definite answer. Yeah. No, we will not get a terminating decimal.
Yeah, totally. Okay, that's helpful. And then now one question I had was for estimation. PS question 15. Is that it? No. Maybe it's not. Huh. PS, this is a supermarket question, no?
Yeah.
That's so strange. It should be 2, 3, 5. It's the product of uh, all prime numbers between I think 1 and 20. Maybe that's what is the product of
That's out. Prime numbers.
yeah, it's between 2 and all the prime numbers between 1 and 20. There we go. No, this is not it. Primes between 1 and 20, the product. That's the question. And I was like, well, how am I supposed to calculate this? Do I just multiply it? I'm sure there's another way of doing it.
Is this 5?
Oh, is it? No. I wonder which question it is.
Is it from the OG15?
Oh, it could be DS.
Okay.
It could be DS15.
No.
Oh, that's so strange. I will find the question and I'll email it to you.
Yeah. But the product of all the prime numbers, so you must be given certain options. What I can think of is, on top of my head, generally they'll give you something like maybe one of the options will be even and rest are odd.
Okay.
And since generally the prime numbers are, but since one prime number is even, so we will certainly get an even product. Okay, yeah, I got it. So the whole idea is that the option will be the one which ends with a 0.
Really? Okay, let's.
Because we have a 2 and a. I'm sure there won't be only one option which ends with a 0.
I have no idea where I have found this question because it's not like I would have done it on my own.
Because if we
maybe try product
of prime.
Huh.
No.
Very strange.
But you might have done the question from some other source. Whatever it is, you will figure out that there will be only one option that ends with a 0.
Okay.
Because I don't see any other logic. Because multiplying so many numbers, not even multiplying, even if you multiply all the numbers to see the units place digit, even that is like which for GMAT. They should not be asking such a stupid question.
I'm sure. Okay, it's okay. Let's not. Yeah, I'll find out where I got it from. And then let me see if I have any other. Yeah, question 80 PS. I just want to confirm the method that I'm thinking of in this. It's the one, it's the sum of all numbers between. So in this, I should just think about it that the smallest, if you take all of them to be 1 over 300, then 10 into 1 over 300 will give you 1 by 3 as one extreme. And the other extreme would be 1 over, 200 into 10.
Correct.
Okay.
Into 100.
And then 87 is 87. I just literally put in the numbers. Like I took n as 7, 8, 9, 10.
Did we do the product of 3 consecutive years?
Sorry?
Uh, did we do the product of 3 consecutive integers?
I don't think so.
Oh shit, we might have missed this. Okay, so let's do
You
this.
know what? I think I need to go back and check, not the class you did before this one, but the one before that. I'll go back and I'll overlook the video, because we did finish at that factorial question, but we may have missed something there.
Okay,
I'll check.
okay. So this is actually a very important concept. When if we are given the product of these numbers, like n times n plus 1 times n plus 2, what does it actually mean?
They're 3 consecutive numbers, and they are,
3 consecutive numbers.
yeah, and they're also
Well,
divisible by 3.
very good. Anything else?
One number is definitely even. Could be 2. I don't know.
Yes, perfect.
But,
So obviously, since there are 3 consecutive integers, we can have even, even, or we can have odd.
yeah.
So in this, 2 evens, and in this, 1 even. But from these 2 scenarios, we are sure of one thing, that we have at least 1 2 in these 3 numbers, and we have at least 1 3.
Yeah.
So product of these 3 consecutive integers in any case will always be a multiple of 6.
Okay.
Right?
Yeah.
Okay. And what can you tell about this case? Even, odd, even.
That it'll be a multiple of 4.
Very good. Anything else?
Multiple of 4, and so it's so there's a 3 in there, there's a 4, so 12.
Very good. And
What else? 6 and 2. I'm just assuming it's 2, 3, 4.
so there are
8.
pure multiples and normal multiples, or we can say we'll do it as higher multiples. 2 4 6 8 10 12 14 16, like this. If we take any consecutive even numbers, 1 will be a pure multiple of 2, that is, one number will have only a single 2. 2 raised to power 1 into 1, raised to power 1 into 3, 2 raised to power 1 into 5, 2 raised to power 1 into 7, only a single 2. And the another one will have at least 2 2's, 2 square, 2 cube, 2 square into 3, 2 4, next one will be 2 raised to power 2 5, like this. If we take 2 consecutive even numbers, we will have at least 3 2's. One from a pure multiple and one from a higher multiple. 2 from higher multiples. So if the first number is even, then we have 3 2's, that is, n must be divisible by 8. second, 3, 1, 3 will always be there.
Yeah.
And if we combine these two, we a multi of 24. So whenever the number starts with an even number, the product of 3 consecutive integers will always be divisible by 24.
Hmm. Okay. Hold on. Can you repeat that? I'm writing it down.
If the product of 3 consecutive integers starts with an even number,
But if it starts with 2?
yeah, even then.
Oh
2
yeah.
into 3 into 4.
Yeah, if the product of 3 consecutive integers.
Starts with an even integer,
Yeah.
then the product of these 3 consecutive integers
Yeah. Is a multiple.
will always be divisible by 24.
Yeah.
And therefore, by every factor of 24. That is 1, 2, 3, 4, 6, 8, 12, and 24.
Yeah. Yeah.
But that we can only say if it starts with an even number,
Yes.
right?
Yeah.
Okay. Now coming on to the next part. N times n plus 1 times n plus 2. Now, in of 3 consecutive integers, the product of 3 consecutive integers, the rule says that exactly one integer will leave a remainder of 0. Exactly one integer will leave a remainder of 1. And exactly one integer will leave a remainder of 2. Whether we start with a multiple of 3 or we start with a number just greater than a multiple of 3, or we start with a number just less than a multiple of 3. In this case, remainder 0, remainder 1, and remainder 2. In the second case, remainder 1, remainder 2, and remainder 0. And in the third case, remainder 2, remainder 0, remainder 1.
Yeah, that makes sense.
Now, this logic is tested in question number 87.
Acha.
How it is tested, we'll be discussing that as well. Now, there is a rule that says if multiple of any number, for example, n is a number and we multiply n by a, to a multiple of n, if we add another multiple of n, the sum of these two will always remain a multiple of n.
Yeah.
That is rule number 1. Add two multiples of the same number. Rule number 2 is add multiple
And non-multiple.
and non-multiple.
Mm.
Now, to a multiple of n, if we add a non-multiple of
It may or may not be a multiple.
n times a plus n times b plus 1, for example.
Mm.
So this number is not a multiple of n.
Yeah.
if we add these two, the resultant will never be a multiple of n. It will always be a non-multiple. Addition of multiple and non-multiple will always
Always be
yield a non-multiple.
Okay.
This is clear?
Yeah.
Okay. Now, the third rule is, and it is very important, adding two non-multiples. We have two scenarios. Sum of remainders is n, adding two non-multiples of n. Sum of remainders is which remainders? Multiple or we are not multiple, the number which we are taking divided by n. Both the numbers that we are taking, both non-multiple divided by n, we will get, obviously, since both are non-multiples, we will get some remainder.
Yeah.
In both the cases. Now, if we add those remainders, if we get, if the addition of those is give n or a multiple of n. Multiple of n is only possible when we have more than 2. Or a multiple of n. We will get a multiple of n. Second case, when we are doing again the same thing, non-multiple, we divide by n to get a remainder for both the numbers. Sum of remainders is not equal to n or not to a multiple of n. Then this will result in a multiple. Now let's see this. We take, for example, we are taking two numbers, 10 and 11. We divide 10 by 3. This will yield a remainder of, and 11 by 3.
2. Yeah.
Yeah.
2 plus 1 is 3.
No. एक काम करना पड़ेगा. एक बार जल्दी से जाओ, एक बार वो मेरा खत्म हो बैटरी. Malika, you need to give me 5 minutes.
Yeah.
Actually, the batteries of my pad are actually gone.
Yeah.
So can we, it's 10:50 on my watch. Can we start at 11?
Yeah, sure.
Thank you. I'll just raise this by then.
Okay. n.
Hello.
Yep.
Yeah. Hi. Okay. So we were discussing if the sum of the remainders of those numbers when divided by n is not equal to n or not equal to a multiple of n, then the resultant will the addition sum will not be a multiple of n.
Yeah.
Now in this case, when we are adding in the first scenario, we took two numbers 10 and 11.
Yeah.
In these numbers, when 10 is divided by 3, we are getting a remainder of 1. And when 11 is divided by 3, we are getting a remainder of 2.
Yeah.
When we add the remainders,
Yeah.
then we get a number which is divisible by 3.
Yeah.
Therefore, 10 plus 11 will yield a number which is a multiple of 3.
Oh, which is a multiple. Yeah, which is divisible by 3.
Now, other case, for example, 20 and a number maybe like 8. 20 by 3 will yield a remainder of, and 8 by 3 will again yield a remainder of 2.
Yeah.
Therefore, since 2 plus 2
Yeah.
is not equal to a multiple of 3,
Yeah.
therefore, the sum of these two numbers will not be a multiple of 3.
Yep.
Make sense?
Yeah.
Okay. Now we have to go back to the question. What we were discussing is when we are multiplying consecutive integers like n into n plus 1 into n plus 2, we will always have one number which will give a remainder of 0, the second one will give 1, and 1 will give you 2. you have to figure out this scenario.
Ah, now I get it. Okay. So that's why when in the first in question 87 in A, you notice that all of them give remainder 0, 1, 2. 0, 1, 2.
Yes. Now, the one thing that we discussed, if for example, 20 by 3, we were seeing that this is giving a remainder of 2. To a non-multiple, if we add a multiple, if I add, I will get a number which will give the same remainder.
Remainder.
Why? Because n times a plus, for example, nb plus 1. This is giving a remainder of 0 when divided by n, and this is giving a remainder of 1 when divided by n. The resultant number will give a
1.
number which will give a remainder of 1 only.
Yeah.
So that means, to example, if I am adding a non-multiple, I will get the same remainder what that non-multiple is giving.
Yeah.
So the easiest way to think of it is that we have to convert the expression into form n into n plus 1 into n plus 2. Now, first, one thing, so these are the two ways. Either you do it this way, or you can pick any number greater than 6 if you are getting 3 distinct remainder.
Yeah.
If we go by remainder is equal to 0, 1 and 2, let's say any number greater than 6. Let's say we are taking 10. So first one, n is giving a remainder of 1, n plus 1 is giving a remainder which is 11. 11 by 3 will give 2, and 10 minus 4 is 6. It is giving a remainder of 0. So that satisfies.
Yeah.
Second, n is 10, remainder of 1, 12 is remainder of 0, and 9 is remainder of 0. Not possible. And 10 is 10 will 1, 13 will give 1, and 10 minus 6 is 5, which will give 2. Again, not possible. N 1, 14, 2, and 8, 2. Not possible. 1, 10 plus 5, 15, which gives 0. 10 minus 6 is 4, which will give 1. Again, not possible.
This is the first method.
Yes. Secondly, what you do is you can try and convert numbers into n plus 1 into n plus 2 form.
Yeah.
That is, so I have to convert everything in this form. So n minus 4, if I add 6 to n minus 4, I will get n plus 2. 6 is a multiple of 3. That is what my target is. I will try to add or subtract any multiple of 3. Addition of a multiple of 3 or a fraction of a multiple of 3 will not change the remainder a bit.
Hold on. So you've added 6. How are you changing it into this format again?
So n matches with n plus 1 matches with n plus 1. I have to convert this to become to look like n plus 2.
Yeah, so you added 6.
Added 6. I can only add a multiple of 3. Because if I am adding a multiple of 3, not changing the remainder.
Okay.
Because if I'm adding a multiple of 3, we discussed, remainder doesn't change.
Yeah.
So whether we are adding NA plus NB, remainder 0, we will get a remainder of 0. If we are getting this and this, then 0 and 1, we will get a remainder of 1 only. So whether we are adding n to NB plus 1, the remainder doesn't change.
Okay.
So I can add number 6 here to make it look like this. Since I can convert it into this form, it satisfies.
Okay.
Now n is there in option B, n is there, n plus 2 is there. Can I add a multiple of 3 to n minus 1 to make it n plus 1? No. If I add 3 to n minus 1, I will again make it convert it to n plus 2 only.
Yeah, you can't do anything to convert it.
Yes. Addition or subtraction of multi 3 will not convert it the expression into this form.
Hmm.
So B is ruled out. Plus 3, I cannot do anything. To n minus 5, I can add a 6 to make it n plus 1. But n plus 3, I can subtract 3 to again make it n. So again, the n plus 2 term is missing here.
Yeah.
So similarly, we can do this. To n plus 4, we can ask 3 to make it n plus 1. But n minus 2, if we add 3, it will again become n plus 1. So n plus 2 term is missing in this. And if we subtract 3 from n plus 5, we will get n plus 2. Addition of 6 will give n only.
Yeah.
So n plus 1 term is missing in this.
So it's actually the same thing because it's actually the remainder that
It is the same thing. We are actually focused on the remainder only.
Yeah.
So that is actually the easiest thing. You can take any number and just figure out what will be the remainders.
Okay.
Make sense?
Yeah. So right now that's all I've done in terms of the practice. I have still right now, I'm starting with fractions and then I have basic equations, quadratic, and
Okay.
then the formulas. So hopefully I'll be done by the next class.
Okay. Now, if you see a question very similar to this one. Yeah, question number 225. Did you try this one?
No, if n is a positive integer, then n into n plus 1, n plus 2 is even only when n is even when n is odd. So 1 is not true because n doesn't have to be even.
Yes, correct. So n can be anything. We will always get an even number.
Yeah,
So
exactly.
this
Even
only when helps us rule out this option.
And then even when only when n is odd, again that's also not true because it's
Perfect.
even either which way
Correct.
because it's a consecutive thing. And then odd whenever n is odd, again it's not going to be odd.
Perfect. Very good.
And then divisible by 3 only when n is odd. No, but right, 1 second, 2. Hold on. Yeah, that's not true.
Always be divisible by 3.
Yeah, it doesn't
The
matter.
product of 3 consecutive integers will always be divisible. Correct.
Looks like 4 by at least by elimination you get E. And then
Yes. So one way is this elimination. So first 4, then obviously E is the answer. Or divisible by 4 whenever n is even. That is true because we cannot say that it will be divisible by 4 if n is odd. But that being said, it will always be divisible by 8 as well when n is even, or 4 as well whenever n is even. So whether it is 4, 8, 12, 24, anything is right.
Yeah, so any factor of 24.
Yes, correct.
But then the thing is, like, what does odd even have to matter about n?
So see, now if anybody thinks about 24 or 8, so they generally tend to overlook 4. That is what given the option E, which is about 4. But it really doesn't matter whenever we are having a product of 3 integers, it will always be divisible by 8 if n is even. But if n is odd, it will never be divisible by 4 or 8.
No, so n is equal to 3. It's divisible by n plus 1, n plus 2 is divisible by 4.
Yes, but here that is a specific case.
Okay, got it.
You say it for every case, 5, 6, or
Yeah,
7.
yeah, you're right. Okay, got it.
Okay. So, what did we do last time?
I know we did this straight pipe 1 yard question for sure, 226. Where did we end? Will you just give me 2 minutes? I have the notes with me. I just need to get them.
Yeah, sure. Good morning. I'm fine. How are you?
Okay, so the last question we did was this is 162 DS. Hello?
160
Is
DS.
5K less than 1000?
Okay. Okay. Fine. Think about the question. Okay. So let's start with. We have covered this parallel lines, intersecting lines.
No. We haven't done. Oh,
We have done only fractions.
yeah.
Okay.
Well, we
So
did
let's.
discuss. I think at some point we did discuss parallel line, but that was like not in terms of coordinate.
No. So no, we are not into coordinate. We are just discussing about linear equations.
Yeah, we did discuss that.
Okay. So linear equations we have done.
Yeah.
Okay. Let's start with quadratic then.
Quadratic also one we did. Number of solutions.
Yes. So did we discuss quadratic formula and
Yeah.
factorization?
Yeah.
Okay. So then we have to start with arithmetic.
Okay.
Okay. The chapter in arithmetic is averages.
Yeah, you're right. We have to start with arithmetic. Yep.
Okay.
Yeah, because I haven't done the homework for algebra.
What do you understand by average?
I guess sum over number?
Sum of all observations divided by number of observations. Right?
Yeah.
So this is the simple average. Simple average is also known as arithmetic mean.
Yeah.
Now, what do you understand by weighted average?
I don't know weighted average. Like sum into something plus, I don't know actually.
So, okay, when do we use average? For example, if I say that you spend $50 per day on an average, it may you have spent $20 on first day, $100 on the second day, and again like $50 on the third day, or $30 on the third day. That means on an average, if I add all these three and divide by the number of days, I will get 1 over 3. So I can say that you are spending $50 per day.
Okay.
That is when you are adding discrete numbers. You have actual numbers and you are adding those values, number of times, whatever number of numbers you have. When it comes to weighted average, so for example, let's take an example of in grade 8, there are two sections, section A and section. Average height of students in section A is 150 centimeters. And average height of students in section B is 180 centimeters. Now, what is the overall average height of students in grade 8?
180 plus 150 by 2.
Okay. So the answer to the questions cannot be determined.
Okay.
Reason is we do not know the number of students in section A and section B. Now, if I add the numbers, let's say number of students in section A is 50 and number of students in section B is 100. Now, what will average height
So
of students in
first
grade
you
8?
find the average height in section A, and then you find the average height in section B, and then you add them.
So average height in section A is already given as 150 centimeters.
Oh, okay. So you find the sum then.
How?
115 to 50.
Perfect. So
Total of height is equal to 7500 centimeters.
correct.
And there the sum of height is equal to 18.
18,000.
Yeah, 18,000 centimeters.
Hmm.
So now that you have that, you can add the total heights and divide by 150.
Perfect. So the point is we still follow the same formula. That is sum of all observations.
Yeah.
So what we are doing is sum of all the heights in A, sum of all the heights in section B, and adding these two to get the sum of all the heights in grade 8.
Yeah.
And then we divide by the number of students in grade 8 to give you the overall average height in grade 8.
Yeah.
Okay. Now, if I say that you should not calculate all this and just by looking at the numbers, you should be able to give a ballpark figure. How can you do that?
Is it by looking at the averages?
Yeah, so just so you can maybe think of whatever you have done. Based on that,
yeah.
you can give.
Mm. I guess it lies between 150 and 180.
Is a very good observation. That is true. So overall average height or overall average can never be less than the lowest observation and can never be greater than the greatest observation.
Yeah.
It should lie between the two numbers.
Yeah. I guess it should lie closer to 180 because there are more number of students. So there's more number of
That
observations.
is very good. Yes, true. And any ballpark figure?
Like, I mean, I don't know how I would come up with that, but maybe like 170, yeah, that. 150.
That is actually perfect. 170 is perfect. We can say that the number here is 50, the number here is 10. The numbers are in the ratio 1:2. For every one student having height of 150, we have two students having height 180.
But isn't that the average?
Yeah. So we are talking about average numbers.
Okay.
So on an average, it should not be 165. 165 is like the actual average of 150 and 180.
Yeah.
When we are not considering the number of students. Now, since it is weighted heavily towards 100, the weight of section B is more because the number of students are more in section B. So the say of section B should be more. It should be skewed towards section B.
Yeah.
So, and how much? What is the difference between 150 and 180? 30. Now we can distribute 30 in three parts. 1:2.
10 and 20.
Yes. So 10 and 20. So plus this has a weight of 10 and this has a 20. That means the difference is so basically it is I can show you on this. So there is a process of alligation. I'm positive that you might not have heard of it, but we will discuss that. So in case to find the average, we prepare a figure similar to X, and the whatever operation we have to perform, we perform along the leg of X. So this should give you 20 and this should give you 10. The weight of this is 20. What should I put here such that the difference between the two numbers will give 20? It should be 170. And we can vary that 180 minus 170 is also giving us 10. That is also correct. So 170 is the number. Now, how do we arrive at that? We will discuss a little more in alligation.
Okay.
It might not be clear now, but once we discuss alligation, it should be clear.
Yeah.
Now, as per alligation, let's say we have two different qualities of rice, R1 and R2. R1 is, let's say, $20 per kg, and R2 is, let's say, $30 per kg. What is the overall average of the we are mixing these quantities in such a ratio that we should be getting the mixture which is 27 rupees per kg. So
Why 27? Or is that just a number you're assigning?
no, so that is the question. We are asked in what ratio should we mix R1 and R2 such that the resultant mixture is $27 per kg.
Oh, okay.
So we are asked to find the ratio. So
will you
that
make
number,
that- yeah. Are you gonna make that table where you write 20 on one side, 30 on one side, and then in the middle there's a circle, like what you just drew?
yeah. So $27 per kg is the overall average that we are trying to achieve.
Yeah.
How to do that? So we have to perform the operation along the leg of X, and what operation? That operation is also higher value minus lower value. We have already discussed that the overall average must lie between the lowest and the highest value, or the lower and the higher value.
It has to lie between 20 and 30.
It should lie between 20 and 30, and we are given that number between 20 and 30.
Yeah.
Now along the X, we need to perform this option higher value minus lower value. Along this leg of X,
7 हो जाएगा और वहाँ 3.
yes, and this side we will get
Yeah.
3. So, and what are we getting now? This 3 and 7 does not represent any number. It is any particular value. It is simply giving us the ratio in which we should be mixing these two quantities. For every 3 parts of R1, we have to mix 7 of R2.
Hmm.
If we draw a line, a vertical line like this, anything on the left of the vertical line belongs completely to R1, and anything that that is on the right of this line belongs completely to R2.
Yeah.
Now, in this, the operation that we are performing is higher value minus lower value.
Hmm.
So this is the ratio in which we should be mixing these two quantities in order to get a mixture which is worth $27 per kg. Now you can see that since the simple average of these two numbers 20 and 30 is 25. If it is skewed towards 30, then the weight of that quantity should be higher in the ratio.
There should be more of the 30 kg rice. 30 per kilo.
Yes. Yes. This makes sense?
Yeah.
Okay. Now I'm just giving you a comparison between methods. Let's go back again to the same question. Section A, section B, 150 students and 180 students.
No, that's the average, no?
The average number. So average students in section A is 150. Average height of students in section B is 180. And there are 50 students in section A and 100 students in section B. The formula to calculate the overall average. Weighted average is represented as X bar is given as N1 X1 plus 2 X2 divided by N1 plus N2. That is what you have figured out.
Yeah.
150 into 50 plus 180 into 100 divided by 150.
Yeah.
Now, let's try the previous question that we did. or the same. Let's first do this one. X bar we need to find out. 150 into 50 plus 180 into 100 divided by 1500 and get 170. Right?
Yeah.
Now, if we go back to the previous question, that is, if we change using the same formula, we just change A into R1 and B into R2. We are given this $20 per kg and this is $30 per kg. We need to prepare a mixture which is $27 per kg. If we put the values in this formula,
So 20 into x1 plus 30 into x2
very good,
over
20 N1 plus 30 N2 over N1 plus N2.
N2 is equal to 27.
Very good. That will give, so 27, if we do cross multiplication, we will get 27 times N1 plus N2. Right?
Yeah.
And if we rearrange, we get 27 N1 minus 20 N1 is equal to 30 N2 minus 27 N2, or 7 N1 is equal to 3 N2, or N1 upon N2 is equal to N2 we take this side and 7 we will take that
Okay,
side.
ratio आ जाता है 3:7.
Yes.
Yeah, N1 by N2 is equal to 3/7. Yeah.
Make sense?
Yeah. Okay.
That is the traditional way of solving it.
Yeah.
But how ideally be solving it is by the of alligation.
Okay.
Alligation is a very, very powerful tool in solving the weighted averages problems, ratios problems, percentages problems, a lot of areas.
Okay.
But we can use alligation only when we are given two quantities.
Fine. Yeah.
If there are three quantities, then we cannot use it.
So okay. Let me right now just get two quantities.
Yeah.
Yeah. Okay.
Shall I erase?
Yeah. I've written it down.
Okay. Now, the same question by using alligation. This is 20. I'm writing units again and again. So many dollars per kg. So many dollars per kg. And there is a reason why I am writing all the units again. And the reason is the first three values, the above three values. All these three values must have the same units. If it is dollars per kg in R1, it should be dollars per in R2, and it should be dollar kg in the middle.
Okay.
Units of the top three values must be same.
Okay, I understand.
And the below two values do not represent anything except the ratio. They are plain numbers.
Yeah.
Okay. Let's try a question. Question number 145 of problem solving.
average daily revenue. Interesting. So on one side you can write first 6 days. On second side you can write last 4 days.
Perfect. Very good. Now
And
this is the
it will be
second
400.
point. This is the second point that I want to highlight. There should not any overlap when you are solving using alligation. Now first 6 days are just separate from the last 4 days.
Yeah.
None of the days overlap actually.
Yeah.
There should be no loss of data as well. It should not be that it is the overall average is given for a 12-day period and you are taking the first and the two quantities as first 5 days and last 5 days. In case there is a loss of 2 days center.
Yeah.
So there should be no loss of data and there should be no overlap as well. Only then alligation will work. Only then you can solve by using the normal method as well. That is n1 x1 plus n2 x2 divided by n1 plus n2.
Yeah. But you like I'm right now making the chart for the alligation method. So I have 360 and then 400 and then I did the math and then 400 minus 360 is 40. So one side of the, yeah, 360. And then you have 400 in the middle.
Very good.
And then on the top right, you have last 4 days. So you don't know that.
Yeah, correct.
And then for the ratios, you have on one side 40. And the other side, you're going to have, here, like I know it's higher minus lower. So the question is,
Perfect. Now, what are those two numbers that we used to get? That actually represents a ratio in one form or the other.
yeah.
That gives you only ratio. That does not represent anything else.
Hmm.
Now we are given that this number 360 is for 6 days and this number is for 4 days. If 4 represents 40, then what will 6 represent?
60.
Correct. Now, what higher value you should take for x such that when you subtract 400,
460.
so it should be 460. Perfect. Now you won't find this method, mention of this method alligation anywhere in any book. But this is a damn good tool. You can save significant amount of time.
Can you just explain how you got the 60? Like I get it, but like the 60-40 split, like 40 I understand. So 60 you got because
yes, so 40 you can get because you are given the actual numbers on the left and at the center. So you can get one actual number, that is 40 here. To get, but since x is unknown, you cannot get a 60. But then again, you will always be given something and figure that out. So this is for 6 days and this value is for now this is the ratio and this should also represent the ratio.
Yeah.
So if 4 corresponds to 40, 6 will correspond to 60 only.
Okay.
It is simply a multiplication. Multiplier 10 is here, then it should be a multiplier of 10 here as well.
Okay.
Or you can write it as, let's say this value is n or y, anything. You say y over 40 should be equal to 6 over 4.
Okay, got it.
So you will get y is equal to 40 into 6 over 4. So this is 10. You will get 60.
Yeah.
Because these are just the ratios. So if you take y as this number, so y is to 40 should be equal to 6 is to 4.
Yeah.
This makes sense?
Yeah.
Okay. Or otherwise, we are given that this is the overall. We know that 360 into 6 plus, we don't know the number, but x into 4 should be equal to 400 into 10. Or we can find the value of 4x is equal to 4000 minus 2160, which is 1840. X is equal to 1840 over 4. It should give you 460.
Yeah.
You see that this involves actual calculations, whereas in this allegation, there is no calculation.
Yeah.
So that is the reason why allegation is extremely fast. And if you know allegation, that will help you solve extremely difficult terms of data sufficiency in like a matter of seconds.
Okay.
Okay, so this is clear?
Yeah.
Okay. Okay, how will you do question number 208?
I mean, I would be thinking about this, that raises the average to 55 units, right? So 15 to n plus 90 over n number of days n plus 1 is equal to 55.
Correct.
That's one way of doing it.
That is correct.
Then you can easily solve for n, right?
Yes, yes.
And then if I'm thinking of it in your method, so one side I will write does the middle number become 55?
Correct. Why it becomes 55? That is the question. For the past n days, the average daily production at a company was 50 units. So I'm writing 50 on the left.
Yeah.
And what does 50 represent? 50 represents average daily production. All the three numbers on the top must have the same. They all should represent average daily production.
Yeah, ADP. Yeah.
If today's production of 90 units, that means this is also 1 day production. That means average daily production for 1 day only.
Yeah.
Second value of ADP is 90.
90, yeah.
This says average to 55 units per day. That means it is also the average daily production.
Yeah.
This is for n days. This is for 1 day. This is 5 and this is 35.
Yeah.
That is 7:1. That means if 1 corresponds to 1, n should correspond to 7.
Yeah.
So that means E is your answer.
Oh, okay. Yeah. I mean, it's the thing is the placement. If you get the placement wrong, then you're in trouble.
Yeah, so that is why I'm making the units while explaining. So it should be that you should understand the top 3 numbers must always have the same units. This makes sense?
Yeah.
Can you try question number 224?
That's interesting. So you're 40 and 60 for CDEX. Is it not possible to make two allegation charts? It almost looks like that because like 25 is to 75 is a ratio and 60 and 40 is a ratio also.
Yeah, but 60 is bluegrass and 75 is fescue.
Yeah. Ryegrass and bluegrass. Ryegrass. Oh, okay. Yeah, so there are three different ones.
Yeah.
Yeah, I don't know how to do this.
Okay.
Now I've gotten confused.
Seed mixture X is 40% ryegrass and 60% bluegrass. By weight, seed mixture Y is 25% ryegrass and 75% fescue. A mixture of X and Y obviously will have some grass that is given as 30, and it obviously will have some bluegrass and fescue.
Yeah.
So first hint here is that since we are the only quantity that is common in both is ryegrass. So that is the first hint, that we have to think about solving it using ryegrass somehow. Now confirmation is this number 30. A mixture of X and Y contains 30% ryegrass.
Yeah.
So the examiner is also asking us to figure out something using the ryegrass.
Yeah.
Now the question is, what percent of the weight of the mixture? That means what part of the total mixture is X? This is the question.
X% of the total mixture.
Yes.
Okay, is okay.
X is what percent of the total mixture?
Yeah.
So what we can do is, we are mixing X and Y.
Yeah.
We know the quantity of ryegrass in X. We know the quantity of ryegrass in Y. And we know the overall quantity of ryegrass in the mixture.
You're specifically doing it for ryegrass and you're making the chart. Got it.
Is 1:2. That means
Yeah.
X is 1 part and Y is 2 part. So 1/2 into 100.
1 plus 2 into 100 is equal to 100 by 3. 33 point. Yeah, so B.
Yes, that is correct.
Interesting. Are there like I mean I know OG has a few questions from weighted average, but are there more I can practice? Because this seems like a topic that I want to do like more.
So yes, I'll be sharing all these topics, the questions. But you understood this part?
Yeah, I think my main like I understood. I mean, I would obviously not real. It's that realization that ryegrass is the one that will help us get to the weight.
So that is, see, once you identify this, then the question is nothing.
Yeah, that. But to get to that, I have to see that the way you circled ryegrass, right?
Yes, this is why I'm focusing more on this part. So understanding should be clear. When we have a mixture X and a mixture Y,
Yeah.
both containing only one element in common and the rest of the elements are different,
Yeah.
then we have to figure out something from the element which is given common.
Yeah, because you have the most information of that common element.
Yes. And then we have a confirmation of this as well.
Yeah.
Examiner also wants us to look at this number,
Mm.
right?
Yeah. Right. Mm.
Okay. Okay. Can you try question number 1?
You know, the employees are either managers or directors. What is the percentage of directors? So it's basically like directors into N1 plus managers into N2 over N1 into N1 plus N2. The average salary for managers is 5,000 less than the total average salary. The average salary for directors is 15,000 more than the total average salary. So total average salary becomes directors into N1 plus managers into N2.
That is perfect. Not total average salary, total salary.
Yeah, total salary.
Yeah.
Now, hold on, sorry. Total average salary means D1 into N1 plus M1 into N2. That's
Total average salary is,
divided by N1 plus N2.
yes, N1 X1 plus N2 X2 over N1 plus N2.
That's the total average salary.
Yes.
Okay.
Total average salary actually means the overall average salary of
And
the
also,
organization.
average salary for managers is basically M1 into N2 over N2.
N1,
Sorry, M1, like I've done like managers into number of managers over number of managers. That's the average salary. I'm just sending you what I'm writing. It'll be
so you also share the screen yourself and write on the screen.
Oh, I can.
Yeah.
Oh, this will stop other screen sharing.
Yeah, yeah, obviously, yes.
Okay, so
Or maybe if you want, I can write as well.
no, here I think.
Whatever.
Can you see it?
Yes.
So I was doing. Oh, I'm not used to this. Oh wait. Okay, yeah, I think it's better for you to do it just because I'm not used to writing on this.
Okay.
I was just trying to do it. I don't know what is the method where you use the regular average, the traditional method. So as per the traditional method, number of managers is M, number of directors is D. Sorry, not number. The salary of directors is D and the salary of managers is M.
Yeah. So let's managers, director,
Yeah.
salary, and number.
Yeah.
So let's say what is the salary of manager you are saying?
M.
M and D.
And
Let's
number
say
is equal to N1.
N1 and N2.
Yeah. Now
Okay.
we said that um, the average salary of managers is equal to M into N1 over N1.
Over.
N1, not N1.
So this will cancel.
Yeah, it's right, no?
Yeah. So we can anyways cancel this. We
Yeah,
have already considered it as M.
yeah,
So getting the same value.
yeah. Oh, yeah, of course. Oh, yeah, because it's average salary. You're right. Okay. Anyway, then the thing is that the total average salary will be equal to D into N1 plus M into N2 over N1 plus N2.
Yes.
And again, because this is average salary, you can write it in the middle.
Yes. So now let's try to do this by using
Okay.
allegation.
Fine. Allegation would mean that you would one side put managers, one side put directors, and then M and D, and then in the middle it would be the big formula, that total average salary.
Now, since everything is given, one is talking about average salary for manager is in terms of overall average salary.
Yeah.
Average salary for directors is also in terms of overall average salary. So let's consider the overall average salary as A.
Yeah.
Then the average salary for manager is 5,000 less than A.
D minus 5,000. And
So
D.
along this leg of X, we have 5,000
Yep.
because these two numbers differ by 5,000 only.
Yeah. And there is.
Now on the other leg, so we completely know that how it works. Only finding one leg of X cannot answer anything.
Yeah. So sufficient. It's not sufficient.
Statement 1 is ruled out.
Yeah.
Now let's come to statement 2. The average salary for directors is 15,000 more than the total average salary.
So
So
50 plus A.
along this leg of X, we have 15,000.
Yeah.
We also know that only this leg of X, we cannot find the answer.
Yeah.
Let's try to combine both of these. When we combine both these values, we will get the ratio 3:1.
Yeah.
Right?
Yeah. Then you can find out percentage.
Yes. Whether it is ratio,
Or
fraction, percentage, everything is same.
yeah.
We need to find the percentage of directors. Every 3 there is one director. Number of directors over managers and directors together times 100. We can find that we have 25% of directors in the organization. Make sense?
Yeah, 1 over 1 plus 3 into 100. Yes. Yeah. Fine.
Okay. Should I erase?
Yes.
Okay. Now, how will you do question number 2?
A convenience store currently stocks 48 bottles, so that's the number of. The bottles have two sizes of either 20 or 40 ounces. The average volume per bottle has the average volume per bottle the store currently has in stock is 35 ounces. How many 40-ounce bottles must be sold for the average volume to be reduced to 25 ounces if no 20-ounce bottles are sold? So one side you'll have 20-ounce bottles, the other side 40-ounce bottles, and 35 in the middle.
That is perfect.
And so there is a scenario when there are no 25-ounce bottles sold, right? That's which means
So, how does that scenario matter? Now, if we are not selling any 20-ounce bottles, how does it change anything?
does the ratio well doesn't the weight go completely towards the 40-ounce bottles?
So, okay. So let's stick to what is given to us first.
Yeah. Okay.
We have 20-ounce
Yeah.
and we have 40-ounce bottles. So overall average volume per bottle is 35. That means
1:3 ratio.
initially the bottles are in the ratio 1:3.
Yeah.
Now, what does that mean if you combine this information with a convenience store currently 48 bottles of mineral water?
So that means it'll be that the total number of bottles is 48 and it has to be in the ratio of 1:3. So we can find out the number of 20-ounce bottles and the number of 40-ounce bottles.
Perfect. So we have the numbers now with us.
Yes, 12 is to 36. Yeah.
Correct.
So now it's saying, oh, now do we start again?
Very good.
Because now
And why?
25 ounce.
Yes. So now we are given a new average.
Yeah. Yeah.
Now, whenever GMAT gives you a question, every single word has a meaning. So they won't give you anything just because they want to make the sentence longer or the question big. First line is utilized, second is utilized, third is utilized. Now there is the question. Whatever we have done, that is the information given to us.
Yeah.
How many 40-ounce bottles must be sold for the average volume per bottle to be reduced to 25 ounces? Now, initially we started at 36 bottles. How many bottles should be sold so as to bring the average down to 25? That is, the ratio of 20 to 40 ounce bottles are in 1:3, and now it is 3:1.
Yeah.
If no 20-ounce bottles are sold, when the question is saying if no 20-ounce bottles are sold, that means they are you a specific scenario.
Yeah.
So what is the purpose of this statement?
um, Basically, I mean, I'm just getting a little confused because it's in the ratio of 3:1, um, which means that right now, uh,
That means the weight of the 40-ounce bottles reducing. Earlier it was higher, and that was reflected in the number of bottles. Now, if the weight is less, that should also reflect in the number of bottles we have.
yeah, so the number of bottles of 40 ounces has gone down, no?
Correct.
So, okay. So, aren't you supposed to check what the new ratio would be of the number of bottles first?
So we have figured out that is 3:1.
But zero is, but the ratio, okay, so I'm confused now. Totally.
So till this point, we are doing figure, right?
Mm.
Now the question started: how many 40-ounce bottles must be sold? And average volume per bottle significantly reduced. It has gone down to 25. So since we are given that actual number 25, so we are calculating the final ratio that we have.
Yeah.
How many 20:40-ounce bottles we have now? So we figured out we have the bottles in the ratio 1.
Yeah.
Every 3 bottles of 20 ounce, we have just 1 bottle of 40 ounce.
Yeah.
Right?
Mm-hmm.
And what is given to us? No 20-ounce bottles are sold. That means we started at 12, so we should have 12 here as well.
Okay.
What does that mean? What's the final number of bottles we have for phones? Let's say that is X. So if we take the ratio, it will be 3/1 is equal to 12/X, because these represents just a ratio. So we get X is equal to 12/3, which is 4. Or we can do it this way. If 3 corresponds to 12, 1 should correspond to 4. Multiplier of 4, both sides.
Okay.
The purpose of this last point is, if no 20-ounce bottles are sold, that means this 12 goes here.
What does that mean? 12.
It means that we started initially with 12 bottles of 20 ounces. If we are not selling any 20-ounce bottles, we must have 12 bottles only at the end.
Oh, we should have 12 bottles.
We started with 12. So,
Yeah.
so if we are selling only 40 ounces and not selling any 20-ounce bottles, final number should also be 12.
Oh, no wonder it's 32 because I get it now. We
Yeah.
started with 12 bottles of 20 ounces. We started with 36 bottles of 40 ounces. Then we wanted to reduce the average volume per bottle and then sell. And so when we sold none. So we're still left with 12 bottles of 20 ounces. And so we must have sold 32 bottles of 40 ounces to be left with 4. That 12:4 is the number of bottles left.
Correct. Perfect.
That makes sense now. Fine.
Good.
Should we end here?
Okay. So fine, and I will send you the email. And when
Yeah, I mean,
we
I could do
connect,
10 and 10 or 20. That's fine either way.
whatever works.
Okay.
So the only thing is that depends how frequently you're planning for the sessions, because for if you want to make for 10 sessions, even that is fine.
Yeah, I mean, either way, it's the same. I can just. That's
Okay.
fine. Just send it to me for for 20, and if I end up doing half, I'll let you know.
Yeah, yeah,
And then okay, fine. I guess I'll just keep trying a few weighted average questions.
yeah. I'll send this document to you as well,
Okay, fine.
the
Yeah,
averages document.
yeah, you can send that. Though the questions look pretty hard, but you can send them.
Yeah, and you will not get a question. So all the questions in this, they are like very different from each other,
Oh, okay.
and you will not get a question that is outside this domain.
Hmm. Fine, fair enough. Okay. So when can we do the next class?
So when
I
can we
think
do?
next week is better just because now I'm going to be busy with my relatives and or I'm leaving for Bombay tomorrow. So yeah. What
So you
about
suggest?
um how does so next week I'll be back in New York. Let me just record this.